All right, so we're going to continue looking at 8.2. So we've already talked about what kind of triangles we can solve with law of cosines. Side angle side and side side side. And did we do the example yesterday of the side angle side in the notes? You did that one? Okay. So we wrote down all the different versions. There were 3 of them. And the pattern is that one side squared equals the sum of the other 2 squared minus twice the product of the other 2 you wrote down right before that times the cosine of the angle across from the side that you started with. Okay. So if we can remember that pattern, that's going to help us when we solve problems. Just to confirm, is that the one that we did yesterday?
Yeah.
So that's easy. So that's side angle side. With side angle side, you have to solve for the side, and then you also have to solve for the angle. So this type of problem covers everything that can happen with law of cosines. This one does not. Okay? With this one, you are never solving for a side. So in the sense of covering everything you need to know, this doesn't cover everything. It only covers how to solve an angle. Now, at a minimum, you're going to have to do law of cosines how many times here? Yep.
2, I think.
Right. You got to do it at a minimum 2 times, and then you can add them up, subtract from 180, and get the third one. If you don't want to rely on anything that you've calculated to calculate other things, you can do that here. You could do law of cosines separately for all 3 of them. Okay? And that way, it will take longer, but if you make a mistake, your mistake will not have an effect on anything else. Okay? The other thing you want to check before you even start the problem is make sure any 2 sides added together are bigger than the third. If they're not, then when you start doing it, you're going to run into getting an error at some point. So just make sure 9 plus 7 is bigger than 5, 7 plus 5 is bigger than 9, 5 plus 9 is bigger than 7. So we're good. Okay? Any 2 sides added together are bigger than the third. So we will get a single solution. You don't have to worry about 2 solutions, but you do have to worry about no solution with side, side, side. All right, let's do beta first. When you have all the sides, you can choose any angle first. Doesn't matter. How does the law of cosine start out that has beta for the angle? Yep.
2b or b squared
equals
a squared plus c squared minus 2ac.
2a and c, yep.
Times cosine of beta.
Okay. So I did some of it as we went. B squared, a squared, c squared, minus 2 times 9 times 5. We need to do that out. What's 2 times 9 times 5? Yep, 90. It's easier to do 2 times 5 is 10. 10 times 9 is 90. All right. What can I do next on the right-hand side? Nick.
81.
Yep, we can add the 81 and the 25 together, and that's going to give me how much?
106.
106. Okay, so we got that. Joe, what's my next step to start getting beta by itself?
Subtract 106.
Perfect. We're going to subtract the 106. Again, negative number here, no problem at all. Not a concern. So we got 49 minus 106. It's going to give me negative 57. So negative 57 equals negative 90 cosine beta. Megan, what's my second to last step to get beta, cosine beta by itself?
Divide both sides by -90.
Yep. Divide both sides by negative 90. That's going to cancel out your negatives, your 90, and your negatives. As far as 57 divided by 90, don't do that out, because it's not going to be a nice number. Okay? So we're going to leave it as 57 over 90 equals cosine beta. And my last step, James?
Take the inverse cosine on both sides.
Yep, perfect. Take the inverse cosine. That's going to cancel a regular cosine. And now we need to type that in. Okay, so inverse cosine of 57 over 90. So if all the sides are given to you as integers, there is no reason to have to round anything in this problem until you get to the very last step. Okay. So the angle for beta is 50.704. So there's no reason why everybody shouldn't get exactly that to 3 decimal places, because there was no rounding unless I made a mistake somewhere. But, okay. Any question on that? Yep.
So with this formula, there is no second answer possibility? Okay.
Nope. No second answer. The only thing we have to make sure of is that any two sides added together are bigger than the third to make sure it wasn't a no solution. Okay, so now, if this was an isosceles triangle, we would be done. Like, if we had sides of like 3, let's say 3 and 5. Well, if you have two sides that are the same, then you automatically have two angles that are the same. So then you could figure out another angle, because it's isosceles, and then you could add them up and subtract from 180. But since this is scaling, we do need to do law of cosines one more time to get either alpha or gamma. So which one do we want to do last? Yep.
Let's get alpha now.
Okay, so now let's get alpha. And how does the law of cosine start out for alpha?
A
Yeah, go ahead, Jeff.
A squared equals B squared plus C squared.
Okay, so A squared equals B squared plus
C squared.
C squared minus
Minus 2BC.
2BC, so 2 times 5 times 7. So 70
Times cosine.
cosine alpha. Okay, just like last time, let's combine our like terms.
74.
49 and 25 is how much?
74.
74. Okay, next step.
Subtract 74 from both sides.
Subtract 74. And what's 81 minus 74?
7.
What is it?
7.
Oh yeah, 7. Sorry. Yeah. So that gives me 7. That's negative 70. Okay. And let's do the last two steps at the same time. What's my last two steps? Yep.
Divide by negative 70,
Divide by negative 70
and take the inverse cosine.
and take the inverse cosine. There you go. So let's see what that comes out to. Inverse cosine of negative 7 divided by 70. You can type it in like that with the negative. That's fine. So we get an angle of 95.739. Okay. Now, if you don't want to rely on those two answers because you're not sure if you did something right, you could do law of cosines one more time for gamma. But for us, I'm going to add those two together and subtract from 180. So I'll do 180 minus the 95, because that one's still on the screen. But then the 50 isn't, so I need to type that in. Okay, that gives me 33.557. Yeah?
Is it, so it's C squared equals A squared plus B squared minus 2BC, minus
2AB. Yeah.
times cosine gamma, right?
Yep.
Whenever you switch on Pythagorean theorem for like a squared, it's a squared equals c squared minus b squared. Wouldn't that take effect in this?
We're not rearranging the first formula though, to get the second and third one. We're not taking like something like distance equals rate times time and dividing each side by time to get rate. We're not manipulating one formula to get the other. We're following the pattern.
For this one, it's always positive.
Yeah.
For that part.
Yeah, we're following the pattern with law of cosines is always one side squared equals the sum of the other two squared minus twice the other two cosine of the angle across from what you started with.
Okay.
We're always following that pattern. Yeah. Yeah. Because there really is only one law of cosines formula, the one that I just said in words. Using different letters, I mean, you could write it hundreds of different ways. X squared equals y squared plus z squared minus 2yz. You know what I mean? You could write it an infinite amount of ways. So any question on that one? So that's a side, side, side. All right, so let's look at a word problem. Okay, like a lot of word problems, if it starts to get really complex, I will give you a diagram to kind of help you a little bit. I might not label everything in the diagram, but I'm going to give you guys a second to copy that down. Okay, and we're going to be finding some distances in that triangle. All right, so let's take a look at what we have here. So it says a surveyor wants to measure the distance between 2 points, A and B, which are on opposite sides of a building. Now, you might wonder, well, why doesn't the surveyor just like take a tape measure and go straight across and just measure the distance? Well, the reason why the surveyor can't do that is there's lions. There's 5 lions in between points A and B. So that would be challenging because the lions don't like tape measures. And there's also
6 frogs.
frogs. But these aren't just any frogs. These are
Poison dart
they're
frogs.
poison dart frogs. So even if you think like you could maybe like go above them or go around them, the dart frogs jump, it's bad. So we got to stay away from that. It's a danger zone. Right? So we're not going to go in there. So the surveyor can stand safely in front of the house and measure take 2 measurements from there. Okay. The first measurement, actually I'm going to take 3 measurements. The first measurement is there's an object that they can point their transit or whatever device they're using at and get the distance to that object, and that's 110 feet. Then they have another object over here that they can point a laser at. Maybe they point a laser at like a mirror and it bounces back and they can measure that time. However they're doing it, they got the distance between points C and B. And that 54-degree angle, that's the amount that they have to turn, like from where they had their laser pointed the first time, and then they rotate, and then they stop. They can measure that angle that they rotated. All right? So that's 54 degrees. Okay, and we don't have a surveyor there, but we could have, yeah, why don't we do that? That's our surveyor. He looks very serious.
Mm-hmm.
He's not messing around with measuring things. Okay, so that's,
Kind of because this house just got swarmed by random animals.
yeah, that's our surveyor at point C.
Okay.
All right, so let's
Yeah, I see it makes sense.
see if we can figure out the distance between points A and B. What kind of triangle is this using the 3 letters?
SAS.
Yeah, this is SAS, which means we need to use
Our specialty.
Law of cosines.
law of cosines. Yep. And all we can do with law of cosines is find the side that's missing, that's across from the angle, but that's exactly what we want to find anyway, so that's perfect. Okay, let's call this side up here, I'm just going to call it x. All right, so let's start out with x squared equals, and what would come right after that if I'm going to set this up with law of cosines, and I'm going to use these numbers. Yep.
X equals 110 squared.
110 squared,
Plus 160 squared.
60 squared,
Minus 2 times 110 times 160.
60.
Minus
And what comes after that?
or times cosine of 54.
Cosine of 54. Yep. So we got one side squared equals the sum of the other two, minus twice the other two, cosine of the angle across from the side I started with.
All right, and I have like 10, 17,000.
So, well, let's do it out. I'm going to do some of this because it'll make it a little easier to type in if I don't have to type all of that. So let's do 110 squared plus 160 squared. Okay, so that's 37,700. Minus 2 times 110 times 160. Well, 2 times 110 is 220. And 220 times 160 is 35,200. Okay, I think we've done as much as we can do on the right-hand side without starting to round. So now, what's my last step I'm going to do? And this is what I'm going to put in on the calculator. Yep.
Square root.
Yep. I'm going to square root both sides. And that is the distance between points A and B. So it's the square root of 37,700 minus 35,200 cosine 54. Just like that. All right, so that gives us a distance between the two houses of 130.42 feet. That's the distance from A to B. And we did it safely. We avoided the lions. We avoided the tree frogs. We're good. We're safe. Math saves lives.
How's field inspection done?
All right. So any questions on how we solve that side angle side?
Your rendition office alarm, bro.
What's that?
It's a security alarm. You got to turn it off.
Yes.
You have to sign. You have to figure out what the numbers to sell with, and then they'll go away.
Okay, so that's law of cosines. Okay, so on the test there will be a word problem, just one that involves either law of sines or law of cosines, and I will start you off with some of the diagram. You may have to fill some things in on your own though, okay, on the diagram. All right, so I'm going to just adjust that a little bit. All right, so 8.1 and 8.2, those were on solving right triangles. 8.3 and 8.4 are nothing to do with solving triangles, but they are connected to each other. And it's how we can work with complex numbers, but in a different way, okay, what's called trig form. What we're used to doing is standard form. Okay, standard form of a complex number looks like that. It's when you have a real part and you have an imaginary part. Why do we want another way to write complex numbers? Why not just use standard form? We already know what it is. Why learn something new about complex numbers? Well, when you have to take something like that complex number, and let's say you wanted to raise it to a power. Well, squaring it's not too bad. right? You can just do 3 plus 2i times 3 plus 2i, and that requires you to FOIL that all out. So you get 9 plus 6i plus 6i, and what's 2i times 2i? Yep.
Is it
-4, right? Because that's 4i squared, and I squared is -1. Okay, so we've done that. And then you can combine like terms, make it 12i, 9 minus 4 is 5, and there you go. So we just multiplied 3 plus 2i times 3 plus 2i. Nothing we haven't done before. But what if I wanted you to do 3 plus 2i to the 38th power? Are you really going to write 3 plus 2i 38 times and then FOIL every pair of them, even with shortcuts? That's still going to take a long time, right? So there's better ways if we have to take a complex number and raise it to a power than to do it like this. Okay? And that's part of what this section will look at. All right. So before we can get to the real advantage of using what's called trig form, we've got to talk a little bit about how we can take standard form and graph it. Because I need you to be able to see this number, 3 plus 2i, in a more visual way. And the way we can graph 3 plus 2i is basically just taking the real part and let that be your first number, and the imaginary part, which is what's in front of the I, and let that be your second number. When you do it that way, you get what's called the complex plane. It's a two-dimensional graphing system, but instead of an x-axis and a y-axis, you have a real axis and an imaginary axis. So the real axis is going to take the place of x, and the imaginary is going to take the place of y. So if you wanted to graph 3 plus 2i, that's the real, that's the imaginary. It would be just like graphing the point 3, 2. That's all there is to it. So it has a real part of 3 and an imaginary part of 2. That is where the complex point 3 plus 2i would be. 3 to the right on the real axis, 2 up on the imaginary axis. You cannot switch the real and imaginary axis. The real has to be horizontal, imaginary has to be vertical. Positive and negative works the same way you're used to. Positive is right and up, negative is left and down. All right, so let's try graphing a few more complex numbers. Let's try -4 minus 2i. Okay, so remember, real, imaginary. Okay. What's my real part of that first number? Yep.
-4.
So we're going to go 4 to the left. And my imaginary part? -2. So we're going to go 2 down. 4 left, 2 down. That's -4 minus 2i. Perfect. Okay, let's try this one. -2 plus 3i. What's my real part for that second one? Lucas?
-2.
-2. So we're going to go 2 units
To the left.
to the left. And my imaginary part?
3
3. So we're going to go 3 units
up.
up. So 2 to the left, 3 up. And that's how you graph that one. The reason I'm showing you how to graph is 2 reasons. One, this distance from here to here is very important. We're going to talk about that. The other thing that's important is the quadrant that the complex number lands in. 5i. Where would that be when we graph that one? 5i. James?
0, 5.
Yeah, there is no real part, so it's 5 units up. That one is not in a quadrant. It's on an axis, which is fine. And how about 6? Where would that one be? Well, Waylon, where would 6 be?
Would it be 6 on the real axis?
Okay, which way?
Right?
To the right. Yep, it's like graphing the point 6, comma 0. 6 plus 0i. There's no imaginary part. And that's also on an axis. Okay, so what we're going to want to start to think about with these points is how far is that point from the origin, and how much rotation did you have to do to get to that point? Okay? There's a certain amount of degrees you had to rotate. So we're going to start thinking a little bit about both of those things, and that's going to help us to get into trig form.
And polar coordinates.
Yeah, and this also connects with polar coordinates, which is something we're going to study a lot more in chapter 9. Yep. All right. So why is that distance? It's kind of like a hypotenuse, right? Why is this distance important? Well, when you're on a number line, what do you call the distance from 0? Some people define what I'm thinking of this way: the distance from 0. It's the
Absolute value.
yeah, it's the absolute value. Well, in 2D, absolute value is the same concept. It's the distance that a point is from, we don't call it 0, we just call it the origin. Right? So the absolute value of a complex number, if you graph it, is the distance that that number is from 0. Now, if you draw in your hypotenuse, just like that, you have a right triangle where the A and the B are the real and the imaginary numbers. How would you get the length of, how would you find the absolute value? Or how would you get the length of that line segment in blue if you know A and B? Yep.
A squared plus B squared equals what would be C squared.
Yeah, and what is that? Well, like what is that thing you just told me? Yeah, it's the Pythagorean theorem. So to find the absolute value of a complex number, you really do the Pythagorean theorem. You are finding the length of a hypotenuse in a right triangle. It doesn't matter what quadrant you're in. Okay, if you're over here, a squared plus b squared equals c squared, that will work in any quadrant. So the absolute value is the square root of a squared plus b squared. Okay, there is no I in this formula right here. I is in the complex number to tell you that's the vertical movement. Okay? But when you're actually finding the hypotenuse, you just use numbers, okay? Real numbers. Okay. Any question on that formula? All right, so let's try that. Let's try the absolute value of 3 plus 4i. Okay. So in that example, first, can somebody tell me what number represents A? Yeah. Huh? 3. That's like my A. And what number represents B. Yeah, yeah. That's just the 4, yeah. So the A is 3 and the B is 4. So filling that into my formula, you're going to have the square root of 3 squared plus 4 squared, which is going to give me an absolute value of, yeah, 5. Yep. And when you want to write a complex number in trig form, you need 2 things. That is one of the things you need. You need the distance that that point is from the origin. Any question on how we got 5 there? Okay. So now we've got to talk about something else that we need. So what I've done here is I've drawn a diagram again of a complex number. This is the complex plane. I wrote my number, instead of a plus bi, I'm starting to use x and y, because I think if I use x and y, you'll associate x better with being horizontal and y with being vertical. I could use a and b. And you notice I put the I before the Y. That is not how you do it in standard form. Usually you put the I after. The reason I put the I before is because we're going to be getting a formula, and I'm trying to match up what I'm going to give you with what's also in your book. And they have the I before. Okay, so this is a complex number. X is the horizontal movement. Y is the imaginary, so that's the vertical. All right, so to write it in trig form, one thing you need to know is R. Does anyone have a guess what the R stands for? Yeah?
Radius.
Yeah, it stands for radius, because the way you really want to think about this problem is that point is on a circle. Okay? It's on a circle that has a radius equal to the hypotenuse of my triangle. And we just learned that the hypotenuse of this triangle is also the what of your complex number. Yep.
Our absolute value.
It's your absolute value. Yeah. So the absolute value of your complex number is the hypotenuse, which gives you the size of the circle that this is on. The other thing we have to figure out is this. Okay. Theta. Theta is an amount of rotation. Right? It's an amount of rotation starting from here and going up to there. We have to figure out how much rotation we have. Right? And we're dealing with a right triangle, so we can use trig functions to work with this. Okay? When we write something in trig form, you're not allowed to use x and you're not allowed to use y. Okay? We can't use those two things. If you use x and y, that's standard form.
That's
Like
why-
that.
That's why they were called A and B.
Yep, that's why we use A and B. So we can't use this, and we can't use this. I is fine, but you cannot use X and Y. So we're going to have to substitute in something for X and something for Y. Let's see if we can come up with a formula for X. What trig function would involve X, this angle, and that radius right there? Yep. Cosine, exactly. What would, I've already started it out, cosine theta equals, and what would go on the other side? Yep. X over R. Perfect. So now I would like to get a formula for X. What would X equal if you solve that formula and get X by itself? Yep.
Cosine.
R times cosine theta. So now we have a formula, as long as we know the angle, which we will. I'm going to show you how to get that. But we've got a formula we can fill in for the x. Now, let's look at using this angle, this side, and you use a different trig function that would involve y. What trig function would involve y? Yep. Sine. So we're going to do sine theta equals, and what would go on the other side, Courtney? It would be y over r, and I want to do the same thing. Get y by itself, and based on that formula, what would y equal? Yep.
R sin theta.
R sine theta. So when you write something in trig form, the two letters that you use are R and theta. You use a radius and you use an angle. If you don't want to call them R and theta, fine, but you need to use a radius and an angle, whatever you call them, not an x and a y. Now substitute those two things in for x and y. And leave the I right where it is. So if you change x to r cosine theta, you would have r cosine theta at the beginning. Keep your plus sign, keep your I, and you would have r sine theta at the end in place of y. Now what does the first term and the second term both have in common for a factor? Yeah?
R.
R. When two things have the same thing in common as a factor, you can factor it out. So I'm going to pull the R out in front. And what's in that box right there? That is the trig form of a complex number. It all comes from taking what you know in standard form and converting it into a radius, which is the absolute value, and converting it into an angle, which we'll talk about how to do right now. So a final answer in trig form could look something like this. Okay, I'm just making these numbers up. 10 cosine 20 degrees plus I sine 20 degrees. That's a final answer in trig form. You don't do that up. You leave it just like that. If you said, well, what about the 10? Should you distribute it and take the cosine and the sine of 20? Well, if you distribute it and do all that out, you're going to be changing what you have in trig form back to standard form. Okay, so you don't want to do this out unless you're trying to check your answer. Okay, so trig form, you need two things. You need R and you need theta. R is the distance from the origin. This part is how I showed you with absolute value. It's the absolute value of your number. Theta is the angle that your point makes with the positive x-axis. So if you had a point over here, that amount of rotation, that is your theta from there to there. Okay, so now we just have to think about how do we figure out theta. We know how to find r. That's what formula do we use to find r? Show you a formula we already knew from before. Yeah.
A squared plus b squared or x squared plus y squared.
Yeah, so we're just using Pythagorean theorem. You're going to know these two sides because I'm going to give you those in standard form. And you're going to use those to find your radius. All right, so if I want to draw this out, here's our point. That's a 90. That's x and y. Call this r. So r squared equals x squared plus y squared. That's how you get the first thing you need. The angle is right here. Now, think about the two things that you're going to be given. If I give you a number like 3 plus 2i, 3 is like which letter in this problem? Yep. That's like my x. And the 2 is like my, yep,
Y.
it's like my y. So you're going to know the x and you're going to know the y. You need to figure out the theta. What trig function would you use to find theta? Yeah?
Arch tangent, or just tangent.
Yeah, so we could start with tangent. And what would tangent of theta equal?
I think it's y over x.
And now, instead of tan theta, if we wanted theta, take the inverse tangent of each side. That is how you find the angle. But if we remember when we talked about inverse tangent always gives you an answer between negative 90 and positive 90. So the problem is that will never give you an answer in quadrant 2 or 3. Could you have a coordinate in 2 and 3? Absolutely. So I'm going to talk about what we do. We just have to adjust this. What we're going to do is, if you have an answer in quadrant 2 or 3, you can still do this, but then you're going to think of it as a reference angle rather than the final answer. We're going to use that, and we're going to adjust it. Okay. And I'll show you how we adjust it. We just have to add something to it. Okay. Any question on how we got theta is inverse tangent of y over x? And again, that formula works exactly as is in quadrants 1 and quadrants 4. Okay, because inverse tangent will not give you an answer lower than negative 90 or higher than positive 90. It just doesn't. So I'll show you what we do in quadrants 2 and 3. All right, well, the first part, that's easy. To find r, you just use the Pythagorean theorem. There's nothing special depending on the quadrant it's in. You just make a right triangle and solve for r. But now, this is why I showed you how to graph complex numbers. If you are in quadrants 1 and 4, you can use the formula that I showed you to find theta, and it will work directly. If you are not in quadrants 1 or 4, okay, how would you know? Well, if I give you a point that has a negative x and a positive y, you're in quadrant 2. If I give you a point with a negative x and a negative y, you're in quadrant 3. If either one of those happen, that formula does not work directly. You have to take that formula, think of that as like a reference angle, and you have to add pi to it. That will make it work. If you take an answer that's between negative 90 and 90, and you add 180 to it, what's negative 90 plus 180? Yeah. 90. And what's 90 plus 180? Yeah.
270.
270. So if you take something that was originally between negative 90 and 90, that's there. If you add 180 to it, you are now between 90 and 270. You've basically shifted that answer to quadrants 2 and 3 by adding 180 to it. 180 if you're doing degrees, pi if you're going to be doing radians. Now, the only thing that can happen is if you are on an axis, you can't really use that formula. Because if I gave you a point like this,
Yeah.
what's the x value of that point right there? Yeah?
0.
0. Well, you can't fill in 0 for x, you'd be dividing by 0. So that's kind of a special case. If you are on an axis, meaning either your x or your y is a 0, you just have to memorize it's 0, 90, 180, 270. Or 0, pi over 2, pi, 3 pi over 2. Okay, so on an axis it's actually easier because then it's also very easy to get the absolute value because it's a straight line distance right on the axis. It's not at an angle where you really need to use Pythagorean theorem. All right, and now we'll do this one, and then it's a good place to stop. It says find the trig form of 2 plus 2i. That's your x, that's your y. What is it that I need in trig form? I cannot have an x and a y. I need to find which two letters. Yeah?
A, B.
So that's like my A and my B. I need what in trig form? There's no A or B in my final answer.
Like a triangle size or
So what letter? Single letter.
you see.
I need an R.
Oh, all right, so
To use trig form, you need an R and you need a theta. Those are the two things you have to find. And when you're done, you're going to fill them in to this formula that we derived, and you're going to leave your answer just like that. Okay. What formula do we use to find R? Yeah.
R squared equals A squared plus B squared, or X squared plus Y squared, which is put our Pythagorean theorem.
Yeah. You're just going to use Pythagorean theorem. Each side is 2. So 2 squared plus 2 squared, that gives me 4 plus 4. My radius is the square root of 8, which is 2 root 2. Now my angle. First, what quadrant am I in? 1, 2, 3, or 4? Clover, what quadrant am I in? Right here. 2. Okay, our point is in quadrant 2. What's the formula to find theta if you are in quadrant 2? Yep.
Theta equals pi plus tangent of x or y over x.
Inverse tangent,
Inverse. Sorry.
y over x. Yep. All right, so let's fill that in. In this case, y is 2, x is negative 2. When I divide them, 2 divided by negative 2 gives me how much? Yep. Negative 1. So I need to do 180 plus the inverse tangent of negative 1. I always do it in degrees first because if it's going to come out nice, it'll come out nice in degrees. Okay, 135. So that's 135 degrees, or if they want radians, you can convert it by hand at the end. Okay. So final answer, I'll do it in radians, is r cosine 3 pi over 4 plus I sine 3 pi over 4. If you want to check that you did it right, distribute 2 root 2 out to cosine 3 pi over 4, and you will get negative 2. Distribute 2 root 2 out to the sine of 3 pi over 4, and you will get positive 2. So you can distribute that out and check it, but that is how you want the final answer. Okay, so that's most of 8.3. we'll try a little bit more with that tomorrow, and then we'll take a look at 8.4. So homework for tonight. Can someone remind me, what was the page?
Here's page 443.
443, thank you.
443.
Okay, so homework tonight is just 8.2. I'm not going to give you any homework on 8.3 till tomorrow.